Welcome back to Judgment Decision Making. My name's Dr. Padilla. Now we're going to talk about regression to the mean. Let's start with some examples. There are outliers in performance. As denoted here, this mascot had outstanding performance, and we know that this is an outlier. We know that it is not likely that he will maybe ever do that again, and that is fairly intuitive, right? We also know that there is performance that is outliers in the other direction.
So important in this game. That was almost comical.
Speaking of the fourth progression, Mike Sanford.
Some of the most fun sports clips involve these ridiculous bloopers where people have uncharacteristically bad performance. It's a shame when you see your own sports team doing this, but it's hilarious to watch professional athletes who are fantastic at their job, right? All of a sudden making dumb mistakes or doing things that they wouldn't normally do. That hurts.
Franklin the third? What about Franklin the second and Franklin the first? You represent the family, boy. I'm shaking my head too, coach.
Let's watch one more. This is my favorite.
Nathan Snyder standing at his 35.
I like this because you see so many people failing.
Still alive inside the 15-yard line.
Everyone failing in this clip. That's fantastic.
Off the punt whiff. And then the ensuing scrum from Nathan Snyder will ID.
Let's watch the slow-mo caption of it.
Punt cover squad for Miami.
Nope.
Unfortunately, this is one of those situations
Missed
that'll
it.
make the blooper
Nope.
highlight reel.
Missed the kick. Nope. Failed to notice picking. All those guys fail. This guy too.
One of the things that you do want to do in the
And it just keeps going.
is pick it up.
Okay, my point here is that even people who are fantastic at their job have very good, exceptionally good performance or exceptionally poor performance. And the concept of regression towards the mean is when there is extreme performance on a first measure, it will be likely to be closer to the mean on the second measure. So after you see that mascot make that amazing shot, or after all of those guys fail on that football play, the next thing they do will probably be about average. They're probably not going to continuously fail or continuously make extraordinary shots. There was just an accident, honestly. And you know, especially in sports, so many shots are made, so many plays are made. You're going to see some outstanding performance and some really poor performance simply by random variation. But then the next performance will likely be a little bit better if it was a poor blooper, or a little bit worse if it was an exceptional performance, which is illustrating this concept of regression towards the mean. Luck is not predictable, unfortunately. Whenever the correlation between two scores is imperfect, there will be regression towards the mean. Let me show you what I mean by this in a data plot. So here we have a chart that shows, or a graph that shows eye color and study hours. Now, your eye color is not related at all to how many hours you study. So this is what the data would look like. There's really no pattern to be inferred here. Now, if there's a perfect correlation, meaning two things are directly related to one another, such as study hours and the number of classes that you take, you see a graph like this, meaning that these two things are directly related, that the more classes you take, the more study hours you need for each class. That's a perfect correlation. Now, when two things are imperfectly correlated, there's going to be regression towards the mean. In this case, we have study hours and your grade in the class. Ideally, they are related, but not as much as the number of study hours required by different classes. So there is some variability in there. If we focus on this particular plot, I want to point out the two data points in red, and they are outliers. The one on the left is bad luck. You might have studied 8 hours for a test, let's say, and you still got an F on the test. Maybe you just messed up. Maybe you were studying 8 hours and you didn't sleep. There's a lot of reasons that could explain this. And see, we're always trying to come up with these explanations, but it could just be random, dumb luck. Similarly, you might have studied under 6 hours and you got a B plus or even an A on a test or in a class. And so this could also be just due to dumb luck. Maybe on a test, if it's multiple choice, you just happen to guess right. It can happen. You take a ton of tests. And this line down the center is what's called a regression line. You're able to get a regression line by taking the average of all of the data points. So if we were to take an average of each of those and plot them on this plot here, you would kind of get this average slope. And what a regression line allows us to do is to make some predictions based on previous data. So if we wanted to know what it would take, how many study hours it would take to get a B, we could look at the location of B on our plot, and we could estimate it would take about 10 hours of studying per week to get a B in this class, on average, because that line represents the average of this historical data here. And note, the next time you're going to take a test or the next classes that you're going to be in, they won't likely be outliers. They'll likely regress to the mean, where in this case, only studying for 6 hours would more likely get you a D in the class. But if you studied for 8 hours, you'd probably get closer to a C. That's kind of the point here, is that there's an average that we tend to go towards when we have very high or low performance. Now, this is interesting because it can be unintuitive. I showed you many intuitive examples, but these are some interesting ones that make you think a little bit. So in this statement, highly intelligent women tend to marry men who are less intelligent than they are. And you might be able to create a story for why that's the case. Maybe highly intelligent women like to, be the dominant person in the relationship. So they want to date someone who's less intelligent than them. We are so adept at sense making, we are looking for causes when it's really just variability. If someone is extremely intelligent, the vast majority of people that are available to date will just be less intelligent than they are. It's just how probability works. It would be more unexpected if a highly intelligent woman also married a highly intelligent man. That's definitely less probable. Here's another one. After a fantastic meal, average food might seem boring. Maybe you had a great meal and now your tastes have evolved. Now you're more sophisticated. No, just a great meal is an outlier, and then the average food that you eat will feel like a reduction in comparison, even though they're just average. Last one, the parents of an extremely introverted child tend to be more social than their child. Again, you can think of all of these causal reasons why that could be the case. Kids are just different than their parents, right? Everyone kind of knows that. But a lot of that can just be explained by variability. If someone is extremely introverted or extremely athletic or extremely anything, other people around them will be less so, just because that is the regression to the mean. They're more likely to be average. Okay, summary of what we've learned today. Regression to the mean is if an outcome is extreme on its first measurement, it will be closer to the mean on its second measurement. And one strategy to try to identify when this is happening is, when seeing extreme performance, assume that the next performance will be closer to the mean. So don't set your expectations too high if you see fantastic performance. Understand that the next performance will probably be average. And similarly, if for some reason you have bad performance in anything, don't worry about it. Your next performance will probably be better. It's honestly probably a lot due to random luck.